In this lesson, you will learn about debugging bottlenecks with pg underscore stat underscore statements. The pg underscore stat underscore statements extension is the single most important tool in a PostgreSQL performance engineer's toolkit. It acts as a flight data recorder for your database, tracking execution statistics for all SQL statements executed on the server. Without it, finding bottlenecks in production is a guessing game driven by slow query logs, which only capture queries that already crossed an arbitrary time threshold. Why every AI and data developer needs pg underscore stat underscore statements? In modern AI applications, especially those utilizing high frequency vector searches with pg vector, chat log history retrievals, or LLM caching mechanisms, performance degradation is rarely caused by a single massive slow query. Instead, it is usually caused by high frequency, low latency queries that run thousands of times per minute. A query taking only 5 milliseconds running 1 lakh times an hour consumes vastly more server resources than a 10-second query running once a day. pg underscore stat underscore statements normalizes query structures by replacing literal values with parameter placeholders like $1, $2, etc., allowing you to see the collective impact of your code. To identify bottlenecks systematically, look beyond total execution time and focus on cache performance and structural efficiency. Let's learn about the architectural mechanics under the hood. So the first one is shared memory allocation. Because pg underscore stat underscore statements tracks matrices across all active database sessions concurrently, it requires a fixed chunk of shared memory. This is why it must be loaded at server startup using shared underscore preload underscore libraries. The second is the query hash. PostgreSQL creates a structural hash of the parse tree for each query. This ensures that select star from items where id is equal to 42 and select star from items where id is equal to 99 are aggregated into the exact same tracking row. The third one is garbage collection. So pg underscore stat underscore statements max. The extension caps the number of unique statements it tracks. Default is usually 5000. If your application generates dynamic raw SQL strings instead of parameterized queries, that is embedding literal values directly, you will overflow this buffer, evicting critical tracking stats. Always use prepared statements or parameterized ORM calls. Hi performance engineers, welcome back. I want you to picture a scenario that almost every developer faces eventually. It's 2 a.m. in the morning time. Your production database CPU is pegged at 99%. Your API response times are dropping off a cliff, and the AI chatbot features you built are timing out for users worldwide. Then you open your application logs. You look for slow queries, but nothing stands out. There is not a single smoking gun query taking 10 seconds to run. So what do? Do you just scale up the database instance, throw thousands of dollars a month at the cloud provider and pray? No, you turn on the ultimate database flight recorder, that is pg underscore stat underscore statements. Most developers don't realize that the biggest performance killers in AI data pipelines are not individual slow queries. It's the micro killers. Queries taking just 3 milliseconds but executing 50,000 times a minute because of a poorly configured loop or a missing cache layer. Let's look at how to expose these hidden bottlenecks instantly. To use it, the extension must be configured in your PostgreSQL.conf file because it hooks deep into shared memory. Once that is active, initializing it in your database is a simple one-liner statement. The PostgreSQL.configuration file is usually found within your installation directory and the version folder, within that the data folder, as you can see here. So within the data folder, in this path, you will find the PostgreSQL.configuration file. Open it in Notepad or any other editor, and towards the end of this file, just add this statement. As you can see in your screen, shared preload libraries is equal to pg underscore stat underscore statement. So this is the line that you need to write in the end of this PostgreSQL.configuration file. So let's do the practical implementation. Before that, the context here is you have been brought in to consult for an AI agent platform. The platform uses a PostgreSQL database to manage semantic long-term memory logs and system prompt configurations. Users are complaining about sluggish interactions. The engineering team claims the database is fine because their slow query alert threshold of 500 milliseconds has never been tripped. Your task is to enable the pg underscore stat underscore statements extension, simulate a heavy repetitive application workload that mimics a poorly optimized database interaction pattern, extract structural execution metrics, identify the hidden culprit, and prove that you have optimized it. So there are few tasks that you need to do here. The first is to enable the pg underscore start underscore statements extension. So for that we have already added the line in the PostgreSQL.configuration file. Then the next action for you will be to initialize the pg underscore stat underscore statements extension. So let's go to the PSQL command line. So let me type this statement: create extension if not exists pg underscore stat underscore statements. So this is the command to create the pg underscore stat underscore statements extension. So as you can see, this extension already exists because I have earlier created this. The second task for you is to build a simulation table called AI underscore agent underscore memory and populate it with seed data. So let's see how can you do that. But before that, once this pg start statements extension is created, you need to make sure that you clear any existing telemetry or any log data so that our experiment matrices are clean. So for that, you need to give this command: select pg underscore stat underscore statements, then need to type the reset underscore reset. So this is the reset function. Okay, it is pg, right? So pg underscore stat underscore statements, right? So as you can see, we have cleared any logs from this extension. Okay, then let's move to our second step, that is to build a simulation table called AI underscore agent underscore memory and populate it with seed data. Okay, so let me copy the command to create this table AI underscore agent underscore memory. So this is what is the command. Let me copy this, go to the command line interface, paste it. So this will create the table AI underscore agent underscore memory. So since I have already created this table earlier for you, so this is already existing. Then the next action here is to insert the table with some base values. So let me copy the SQL statements here. I'll copy this. I'll go to the CLI once again. I'll paste this command. So as you can see, the sample records has been inserted into the just created AI underscore agent underscore memory table. The next step, that is the third step, is to run a multi-statement workload script to generate telemetry or the log data. So the command here is, this is the command to simulate high frequency application interaction loops. Run this block multiple times to mimic real traffic, so and get the analysis and the logs, that is called the telemetry data. So I'll copy each of these statements here and I will paste it here. Just press enter. So it is capturing the telemetry data. Just press enter few times and you will come to the prompt. Okay, so keep pressing the enter key and you will come to the prompt. So you have to repeat all these statements by changing the agent ID. So this is something that you need to do. As you can see, I'm just changing the agent ID and the SQL statement remains the same. Maybe you can copy everything at once and let's see if this takes the command or not. Oh, okay. So I have executed it in one go. So you can also do that. So after you execute these select statements, we'll have to go to the next task. That is the task number 4. Task number 4 is to write a diagnostic performance query to isolate queries with a low cache hit ratio, that is below 95%. Or exceptionally high execution counts. So this is the query to execute the triage diagnostic query. This locates the exact query patterns, draining the shared buffers, cache, or skipping execution volume. I'll paste it here. As you can see, this has given me the output by executing the triage diagnostic query, and by spiking execution volume. The next task, the fifth and the last task, is to implement an index optimization to resolve the bottleneck and reset the statistics to verify success. So the previous step, we executed a statement to spike the execution volume. So let's move to the fifth and the last step. As you can see, so before executing the last step, you need to create an index on the AI underscore agent underscore memory table. So I've copied that code, I'll paste it here. So this will create an index statement. So I'll paste it. As you can see, the index, this index is already existing, that's why you are getting this error message. Now, the last and the most important step is to implement the index optimization to resolve the bottleneck. So let's go to the last query here. So before executing the last query, you can again reset the statistics tracking and run the workload again to verify the engineering fix. So I can reset the logs of the statistics again. So as you can see, this is the statements. Then I will run the workload queries again and then review the metrics. So let's run the workload queries again. So you have to run these queries. As you can see, I have run these queries. Then the last step is to review matrices again to confirm the mean time in milliseconds, and it should have been dropped significantly and cache hits should have been stabilized. This is what is the command that we need to execute. So let me select this command, paste it here. As you can see, the mean time, the milliseconds has reduced. If you see the mean underscore time underscore the milliseconds column, it has reduced significantly. So this is the way to execute all these queries. And as the last step, you need to review the matrices to confirm the mean time should have been dropped significantly and the cache hits should have been stabilized.